All right, from lesson 1 in unit 2 here, I'm on question number 4. And it says write each of the following vectors as a linear combination of I and j. So the reason I get a lot of questions is because people think this question's, they're expecting something harder than it really is. So I'm going to do the A and B for you, and then you can try the rest, but you're going to see that it's actually not that difficult. So it wants us to write a linear combination using I and j. So remember, I and j are simply unit vectors that point down the x-axis. So they have a value or magnitude of 1, magnitude of 1, pointing down the x and y axes. So the first question, vector p, to write it as a linear combination, I'm going to take the unit vector I, I'm going to multiply it by -4, and that will get me to this location here. Vectors up here. So now I have to go up the y-axis 5 units. And that's it. So basically, they just want you to write it in algebraic form, same as what it was from unit number 1. Similarly, they're just going to throw it at you in kind of different pieces of information. The position vector of point 8, -3, so over here. So this is your position vector. So it's just saying it's a displacement. That's all that position means when it says position vector. So in this case, it's going to be 8i minus 3j. So again, it's not the fact you don't know how to do this, it's that wording. So linear combinations are just writing vectors in terms of 2 other vectors. So I and j count as 2 other vectors. So we're just using them to move from start point to end point. If you have any questions, let me know.